guys, welcome to my channel. I am Bad Buddy. So here's my topic, electrostatics. As I'm a student, we feel much difficulty in this subject, EMTL, electromagnetic and transmission lines. So I just want to start video on this subject. So from the subject I start the topic electrostatics. So in this electrostatics we see the coordinate systems. Why coordinate systems? Because in this we use the charges and much more derivatives which are done in the coordinate system. In order to describe the spectral variations of the quantities appropriate, coordinate system is required. So as I say, a point or vector can be represented in the collinear coordinate system that may be orthogonal or non-orthogonal. An orthogonal system is one in which the coordinate systems are mutually perpendicular to each other. So as we see three coordinate systems in the rectangular, those are x and y and z, which are perpendicular to each other. As I say, as example, as we all know, the different coordinate systems available are Cartesian or rectangular, circular cylindrical, spherical, elliptical cylindrical, hyperbolic cylindrical, parabolic cylindrical, much more of them. The choice depends on the geometry of the applications. So the frequently used here are rectangular, cylindrical and spherical coordinate systems. Those contains three coordinates which are mutually perpendicular to each other and contains each unit vector for them. Those are small x, small ay, small aj. So in this picture you can see those things. X, y, z for the rectangular coordinate system or Cartesian coordinate system. For those ax, ay, az are the unit vectors. So we can represent the vector form of Cartesian coordinate system as A is equals to a capital Ax small ax plus capital Ay small ay plus capital Az small aj. Capital Ax, capital Ay, capital Az are the vector representations, and Ax, Ay, Az, those are small, are unit vectors which are multiplied and added together to get the A. This is a point where range of variables, as we see in this coordinate system, there are three variables x, y, z. Those values are from minus infinity to infinity. So let's go to the differential displacement in this coordinate system. It's given as dl is equals to dxax plus dyay plus dzaz. As we see the vector quantity, here A is equals to capital A ax plus capital A by ay plus capital az. So as we differentiate them, we get this expression. Differential length for the surface is given as dl is equals to dxax plus dyay, as we keep the z constant, and dl is equals to dyay plus dzaz, as we keep x as constant. Dl is equals to dxax plus dzaz for y constant. So as we keep the constant, the differentiation becomes 0. As we know that the differentiation of a constant is 0, so from the upper equation we get these lower three equations. When we keep these x, y and z coordinates as constants. So length for the line parallel to x, y and z axis are represented as follows. As we see, for line parallel to x axis, the y and z coordinates are constants. So dl is equal to dxax, and similarly for y axis and z axis. So differential normal surface element ds. The differential surface element, that is the area element, is defined as d capital S is equal to d small s an, where d small s is the area which we are taking and an is the unit vector which is passing perpendicular to that surface which we are taking. So Here an is a unit vector, as I said. From the first figure, in the figure, a capital S is equals to dy dz ax, as dy dz is small ds, the area of the surface, and ax is the perpendicular unit vector that is passing through that surface. From the second figure, you can see d capital S is equals to dx dz ay, and third figure d capital S is equals to dx dy az, as dx dz is the surface and ay is the unit vector passing through the second figure's surface, and from the third figure dx dy is the surface and az is the unit vector that is passing through it. So differential surface is basically a cross product of the components or parameters which we take as a surface. If we take the yz surface, dy dz are the components and the unit vector which is perpendicular to is ax. So as we see, the differential surface ds is equals to dy cross product of dz. dy cross product of dz is equals to mod dy mod dz an sin theta ab, and that is equals to dy dz an, as sin theta ab is equals to 1, where theta ab is the angle between the two components or parameters which we are taking as a surface, that are dy and dz, which are perpendicular to each other. So angle between them is 90 degrees. As it is 90 degrees, sin theta is equals to sin 90 degrees. So sin 90 degrees is equals to 1. Then the product which we get is this. So where an is the unit vector normal to both dy and dz, that is get from the an is equals to ay cross product of az. Ay cross product of az is equals to x. In other words, the differential surface element ds has an area equal to the product dy dz and normal vector that points in x direction. The differential volume element dv, differential volume element dv can be expressed in terms of triple product dv dx is equals to dy cross product of dz. Consider a cubic surface having the dimensions x, y, z, then the volume will be x cross y cross z. So the same thing we do in this differential volume elements. So we triplet product the dimensions x dx dy dz. So dv is equals to dx dot dy cross product of dz. Since cross product of any element is mod a dot mod b sin theta, if we do the ab cross product, and ax dot ax is equals to 1, ax dot ay is equals to 0. If we dot product the same unit vectors, the resultant will be 1, and if you dot product the two elements which are different, then the dot product of those elements is equals to 0. So if we cross product the two elements ax ay unit vectors, then the resultant will be az, and if we cross product ay and az, then the resultant will be ax, and if we cross product az and ax, the resultant will be ay. As we see in the last one, here you can see ds is equals to dy cross product of dz, where dy consists of its unit vector ay and dz consists of its unit vector az, and those cross product is ax. So as a resultant we get an is equals to ax. So for further discussion, dv is equals to dx dot of dy cross product of dz. We know dy cross product of dz is dy dz ax, as we get from the last one dx ax dot dy dz ax. Here we can see the right and the left have ax as a common element, and ax dot ax is equals to 1 is the dot product of the same elements unit vectors. So the dot product of these two elements becomes the resultant one dx dy dz, where dy and dz are the mutually perpendicular to each other. Therefore the angle between them is 90 degrees. Since I said it before, the sine theta AB, where theta AB is 90 degrees, as we get that from this. Okay, here you see the dot products ax dot ax, that is similar dot products, is equals to 1, and ax dot ay, those are different dot products, that's equal to 0. This is applied to the unit vectors. We must consider the unit vectors when we see the dot product multiplication. The same elements will multiply, and if there are different elements, then those elements cannot combine. But in the cross product, if we cross product ax and ay, we get az. Ay and az, the cross product of them is ax. So xyz are the parameters which are perpendicular to each other in this coordinate system. So those coordinate systems unit vectors are also perpendicular to each other. Coming to the cylindrical coordinate system, here we see the three quadrants. Those are rho, pi and z. Rho is radius and pi is an angle which is also called as azimuthal angle, which is the angle between the radius rho of a cylinder from origin, you can see that, and the x-axis. So the vector form of the cylindrical coordinate system is A is equals to capital AZ small az plus capital A rho small a rho plus capital A phi small a phi. Here AZ, A rho and A phi, which are small, are called as unit vectors to those coordinate system coordinates. So x is equals to rho cos pi, y is equals to rho sin phi. How these values are occurred? So from the figure above, the figure 1, we can see that the x-axis, so as it formed the right angle triangle, from this we can say that the x component becomes rho cos pi and y component becomes rho sin phi. As we see the rho as the hypotenuse, we get the x component and y component in the form of rho and pi. Here from this, if we square and add the x and y values, we get rho square whole to sin square phi plus cos square phi, that is equals to rho square, and rho is equals to root over x square plus y square. Simply similar, y by x, if we take the x and y values and divide them, the tan phi occurs. So as we see that sin phi by cos phi is tan phi. So the phi value is equals to tan inverse of y by x, and z remains the same. For this cylindrical coordinate system, these are the conversions. Now coming to the spherical coordinate system. In this coordinate system, we see both the cylindrical coordinate system is coming to here. For the x and y plane, you can see that consider the same process for the cylindrical coordinate system which we considered into the spherical coordinate system in the x and y plane. In that two plane, you can see the right angle triangle which consists of angle phi. So the coordinates becomes y is equals to rho sin phi and x is equals to rho cos phi. Okay, here we consist of three quadrants. Those are r, the radius, and theta, the angle between the x-axis and the radius of the sphere, as we see in the figure. So, and phi is the angle between the x-axis and rho, that is the radius of the cylinder, as we see here there. So from the figure, we can take the right angle triangle Z R rho. Here we can see the right angle triangle at the angle 90 degrees at Z point. So, and theta is the angle between the z axis and the radius r. So, as we consider the right angle triangle, the z by r, that is equals to cos theta, that is adjacent by hypotenuse. Adjacent by hypotenuse is cos theta. As we see, the adjacent side to the theta is z and hypotenuse becomes the radius r. So, z by r becomes cos theta and z is equals to r cos theta. And rho is equals to r sin theta. From the figure we see that we get from the cylindrical, as I discussed before. So, from these two, we get x is equals to rho cos phi, that is equals to r sin theta cos phi, and y is equals to rho sin phi, as we see, and that is equals to rho value r sin theta into sin phi. So, z is equals to r cos theta, as we see there here. As we see there, z is equals to r cos theta, and if we square and multiply x and y values, we get r square sin square theta cos square phi plus r square sin square theta sin square phi. As we take common r square and sin square theta, we get cos square phi plus sin square phi, which is the value equal to 1, and the resultant value for x square plus y square, we get that r square sin square theta. And if we add the z square to it, r square sin square theta plus r square cos square theta, that is equals to r square of sin square theta plus cos square theta, that is equals to r square, as sin square theta plus cos square theta is equals to 1. So, we get r is equals to root over x square plus y square plus z square, and similarly theta we get tan inverse root over x square plus y square by z, and phi value we get tan inverse of y by x.
So here's the summary. For the rectangular coordinate system, and now for the cylindrical coordinate system, and now for the spherical coordinate system. And thank you. Please like, share and subscribe to my channel. I'm Bad Buddy. Thank you.